Richard Feynman once described his earliest scientific education. It did not begin in a laboratory. It did not begin with formal teachers. It began at home, on his father's lap. His father would sit with Encyclopedia Britannica open. Page after page, they explored the world. Not as memorization, but as translation. Not as information, but as understanding. One day, they read about dinosaurs, massive ancient creatures, described in measurements. Numbers filled the page, precise but abstract. 25 feet tall, 6 feet wide skull. These were just numbers, until his father intervened. His father paused reading and asked something unusual. He asked his son to imagine it physically. He said, "Let's translate this." He pointed outside, toward their front yard. He said, if it stood here, its head would reach near the window height. Not perfectly fitting, but nearly touching it. Its skull too wide, glass would shatter instantly. Suddenly the numbers became real objects. Not symbols anymore, but physical reality. This was the lesson. Translation creates understanding. Not memorizing facts, but converting meaning. Feynman later said, "This changed everything." From that moment forward, he approached knowledge differently. Every sentence he read required translation first. Every statement encountered required physical meaning. Words alone meant nothing, without reality attached. This became his foundation for scientific thinking, not accepting information until it became real, not trusting abstraction without concrete visualization. His father never pressured, never demanded performance. There was no authority, only shared curiosity. Only discussion existed between father and son. Curiosity guided everything, naturally and freely. There was no fear, only fascination present. Science became exploration, not obligation or burden. The world became understandable, not distant or mysterious. Feynman remembered clearly the emotional impact involved. He was not frightened by massive dinosaurs. He was fascinated instead by their magnitude. Reality became expandable through imagination and reasoning. His father showed him how to see properly. Not just observe, but truly understand. This distinction mattered deeply throughout his scientific career. Years later, another lesson emerged. This lesson involved a simple bird. One child pointed upward, toward a bird flying. The child asked him, "What bird is that?" Feynman replied honestly, he did not know. The other child responded with apparent confidence. He named the species with exact terminology. But Feynman knew this was incomplete knowledge, because his father had taught him differently. His father once explained the nature of naming. He said, "I can teach names. In many languages, different labels exist. But after learning names, you know nothing still. You only know labels, not the reality itself." Understanding requires observation, not memorization of terminology. His father then said, "Watch the bird closely. Observe its movement, observe its behavior. See what it does, not what it's called." This distinction became permanent inside Feynman's thinking. Names became secondary, understanding became primary. Reality became the goal, always, and without exception. And this lesson defined his entire life. The speaker pauses briefly. Then he continues calmly. He says that Richard Feynman explained something deeper, not about objects themselves, but about their identity. He said this clearly. Identity comes from atoms, not from appearance alone. Everything you see, everything you touch, everything you feel, it is atoms moving. Atoms rearranging endlessly. Atoms exchanging constantly. The rock feels permanent, but permanence is illusion. Stability hides motion inside me. Inside the rock, atoms vibrate constantly. They never truly stop. They oscillate quietly, locked in structure, bound by forces. Invisible forces holding them, forces without shape, forces without color. Feynman emphasized this truth. Nothing is truly still. Stillness is approximation. Even frozen matter moves. Even silent objects vibrate. Even darkness contains motion. This changes perspective completely. The rock is alive with activity, not biological life, but physical activity. Fundamental dynamic existence. The speaker explains further. He slows the moment. He narrows the focus. He asks you imagine. Imagine shrinking smaller, smaller than imagination allows, smaller than molecules, smaller than atoms, into atomic emptiness. You would see space, vast empty regions. Mostly nothing exists there. Atoms are mostly empty. Matter is mostly void. Solidity is deception. Feynman loved this paradox. Solid things feel dense. Yet density hides emptiness. Your hand feels rock, but atoms never touch. They repel each other. Electric forces push apart, preventing true contact, creating illusion of touch. Touch is force interaction, not physical merging, not actual collision. This realization feels strange. It challenges intuition. It reshapes understanding. The speaker continues carefully. He respects the idea. He presents it honestly. He says consider time, not human time. Atomic time scales. Atoms exchange positions. Atoms leave structures. Atoms join new forms. The rock changes slowly. Too slow to notice. Too slow to see. But change happens always. Every second passing. Every moment flowing. Feynman pointed this out. Nature never freezes. Nature never pauses. What appears permanent is temporary arrangement, temporary atomic agreement. Atoms do not care about human meaning, about human ownership. They follow physical laws. They follow energy rules. They follow probability patterns. This creates reality. This builds existence. This shapes everything. The speaker reflects quietly. He lowers his voice. He deepens the thought. He says something important. You are also atoms, not separate from rock. Same particles inside. Same physical rules. Same universal origin. Your body feels permanent, but atoms change constantly. Cells replace their atoms. You are dynamic structure, not fixed object, not permanent arrangement. Feynman found beauty here. Not sadness or fear, but deep wonder. Because permanence is illusion, and change is fundamental, change defines existence. The rock tells story, not through words, through its structure. Structure shaped by physics. Physics shaped by reality. Reality shaped by atoms. This connects everything, from rocks to stars, from dust to life. The speaker pauses again. He lets silence speak. He lets understanding settle. Because this realization matters. Not just scientifically, but philosophically too. It changes how you see, how you understand existence, how you perceive reality. The ordinary becomes extraordinary. The simple becomes profound. The silent becomes meaningful. All because of atoms. All because of physics. All because of truth. And Feynman wanted this. He wanted people seeing. Seeing beyond appearance. Seeing hidden reality. Seeing invisible motion. Seeing atomic truth. The rock is teacher. Quiet but honest. Simple but profound. And its lesson remains. Everything is changing. Even when unseen. Everything is moving. Even when silent. Even when still. Feynman once described a lesson beyond physics. It was about humans. About authority and respect. He recalled childhood moments with newspapers and photographs. One image showed a powerful leader. Crowds bowed respectfully. The leader stood tall. Feynman asked gently, Why do people bow? His father explained, it is uniform, not merit. Position does not equal intrinsic superiority always. Titles create illusion. Costumes create perception. Power is often symbolic. He emphasized clearly, question authority respectfully. Respect ideas, but not hierarchy blindly. Blind obedience blocks thinking. Curiosity requires independence. Truth matters above reputation. These lessons guided him through scientific career. He challenged established theories without fear of judgment. He questioned professors openly, not arrogantly, but honestly. He valued doubt highly as essential tool. He taught that knowing is not the same as understanding reality. Years later, after MIT, his father asked a fundamental question. He asked about atoms and photons emitted. Does photon exist beforehand or appear only later? Feynman explained carefully, photons arise with electron motion. They are not stored, they are created dynamically. But even this explanation was unsatisfying. Some truths remain beyond complete understanding. This reinforced a lesson learned long ago. Honesty matters more than pretending knowledge exists. It is acceptable to admit ignorance. Pretending certainty is dishonest and misleading. He carried this mindset throughout life. Feynman respected questions over easy answers. He sought reality, not comfort from labels. He emphasized translating abstract ideas into intuition. Equations without understanding are meaningless symbols. Words without observation are incomplete knowledge. He valued curiosity freely, without pressure or hierarchy. He taught through examples, not through authority. The red wagon, the birds, the photons, all became tools for understanding reality. Understanding first, naming second. Observation first, labels later. This shaped everything, from early childhood to quantum electrodynamics later. Feynman's lessons remain for all learners today. Question respectfully. Observe carefully. Translate numbers to meaning. Admit ignorance honestly. Value curiosity deeply. Respect reality, not position. He showed through life how learning truly works, not by memorizing facts, but by comprehending deeply. Not by following blindly, but by exploring actively. Not by fearing uncertainty, but by embracing it. Every child can learn. Every mind can explore. If guided gently, with honesty and curiosity, like Feynman's father guided him. The speaker concludes thoughtfully, this is the essence of Feynman's education. It is a method of seeing reality clearly. It is a philosophy of living with integrity. It is a legacy passed from father to son, and now to the world. Everything observed, everything questioned, everything understood matters. Reality is primary. Understanding is everything. Curiosity guides discovery, and that is why Feynman's thinking still inspires.